Okay, so we have question 1 on multiple choice questions. It says 4 possible options are provided as answers to the following questions. Choose the answer and write down A to D next to the question number, 1.1 to 1.10 in your answer book. For example, if you feel that the answer to 1.11 is D, then you're going to write it as 1.11 and then you say D. Now, 1.1 says safety belts in cars are designed to reduce the extent of injuries to passengers during accidents. Which one of Newton's law of motion best explains the tendency of the passenger's body to move forward during a head-on collision? Right. So when we are speaking of that, we know that we are speaking of inertia, right? So that's the resistance of the body to its change in motion. And then we know that inertia relates to Newton's first law, right? So when we are looking at the options here, where do we see Newton's first law? Can see it there. It's option B, right? 1.2 says an object of mass m rests on a flat table if the action force of the earth on the object is mg. Which one of the statements given below best describes the reaction force? Now, when we are talking about the action and reaction force, we know that that relates to Newton's third law, right? Now, Newton's third law says when object A exerts a force on object B simultaneously exerts a force of the same magnitude, but in opposite direction. So if the action force is the earth exerting a force of mg on the object, then we are expecting the force, we are expecting the object to exert back the force on the earth. Now the earth, we know that it is exerting a downward force on this particular object. So that means the object must exert what? An upward force back to the earth. So we want to look for an option that is talking about the action-reaction pair of the earth and the object. Looking at option A, we can see they say the table pushing up on the object with force mg. Now you can see they're talking about the table and the object, but then the question is asking us about the earth and the object, so not the correct action-reaction pair. Now let's go to B. It says the object pushing down on the table with force mg. Again, the object and the table, not the correct reaction, the action-reaction pair. Then C says the object pulling upward. Note this, the object is doing what? Pulling upward on the earth with a force mg. So that makes it the correct one, because if we check D says the table pushing down on the floor. So this one is totally incorrect because it's now talking about the table and the floor. So C becomes the correct option, right? Number 1, because the force is acting in the opposite direction of the force of the earth, and then also it is being exerted on the earth. So that corresponds to our Newton's third law. Now 1.3 says a constant net force F acts on a box which moves along a frictionless horizontal surface. Which one of the following quantities remain constant while the net force acts on the object or on the box, right? Now they just said a constant net force. We know that when they mention constant net force, a constant net force helps to bring about a constant velocity, right? Now, if there is a constant velocity, we know that a constant velocity means that we have zero acceleration. So in all these options, we are looking for something that will be talking about acceleration here. So is it A? Is it the change in momentum? Definitely not. Is it B, the work done on the box? Not quite. Then C, is it the rate of change of velocity? Or D, is it the change in gravitational potential energy? So this one, incorrect, totally incorrect, and then incorrect as well, right? But then let's check here the rate of change of velocity. Now, if we are saying there is constant velocity, this means there is zero acceleration. But then note that they did not say acceleration here. But then for the sake that they said rate of change of velocity, that is the definition of acceleration. Because acceleration, we know it as the rate of change of velocity. And then this is the part that will be kept constant here. So Our option is C. So always note how they play around with these options here. Okay, now we go to 1.4. We have 1.4. It says a ball is dropped from a hot air balloon that is moving upward at a constant velocity. So note that it's moving at a constant velocity. And then this ball is dropped from that moving hot air balloon. They say take upwards as the positive direction, and then the correct velocity versus time graph for the motion of the ball and the balloon is. Now, looking at all these options, if they took upward as positive, we know that the general shape of the velocity versus time graph should always be a decreasing function. Now, looking at option A and B, we can tell that these are completely incorrect because, as we can see here, they do not represent upward as positive. So this one is incorrect, and also this one is incorrect. Now, it's a matter of having to choose between option C and option D. But then what will help us decide is the fact that we know that if an object is to be dropped inside from inside a hot air balloon that is moving at constant velocity, what we know is that the velocity, that constant velocity of the balloon, will be equal to the initial velocity of the ball, right? So always note your Newton first law there, saying because this will be moving at that particular constant velocity. Let's say the constant velocity is 5 meters per second. Even though the ball is said to be dropped, the velocity of the ball will not be 0, but then the velocity of the ball as well will be 5 meters per second. So that means between these two graphs, we are looking for the graph whereby the initial velocities of the two objects, which is the ball and the balloon, will be the same. But then when we are looking for the initial velocities, we know that we are looking for the y-intercept, because in a velocity versus time graph, the y-intercept always represents the initial velocity. So we want to spot a graph whereby there will be an intersection on the y-intercept. And then looking at option C and D, we can see that D is the perfect one, because look at here, the initial velocity of both the balloon and the ball is the same. So option D becomes the correct answer. Right. So you don't just guess when it comes to your multiple choice questions. You have to actually put in the work to actually figure that out. Then 1.5 says, two forces, each of magnitude 200 newtons, are simultaneously applied to a toolbox of mass 25 kg, resting on a horizontal surface as shown in the diagram below. Ignore the effect of friction. Then they say work will be done by the net force on the toolbox because it will A, accelerate to the left, B, accelerate to the right, C, be lifted off the surface, or D, remain at rest. Now we can tell that D is completely out from here, because there is no way this block can remain at rest with all these applied forces here. So as much as the applied forces are the same magnitude, but then considering the angle here in which this one is applied, or considering the way in which they apply, this one is applied horizontally, but this one is applied at an angle, meaning that the effect will not be the same. Remember, if you apply a force horizontally versus when you apply it at an angle, it does not have the same effect. Now, that means this one is out. And then let's look at C. It says it will be lifted off the surface. Not true. The fact that it is being this force is being applied at an angle doesn't mean that the object will be lifted off the surface. We know that you can apply a force at an angle, but then your object will still be moving on a horizontal plane. So C is definitely incorrect. Then now it's a matter of checking between A and B. Will this object accelerate to the left, or will it accelerate to the right? Now it's a matter of understanding between the horizontal force and the force that is acted at an angle, which one is a greater pulling force. So obviously the 200 newtons will come exactly as it is, but then the 200 newton that is being applied at an angle, it means that we'll have to resolve this to the components, and then we will have our Fy, and then here we'll have Fx. So that means the component that will be responsible for the movement of the object, or that will be doing work on the object, is the horizontal component here of the force applied. So that means we would have to check for the magnitude of Fx and compare it to the magnitude of this force applied here. Now, what are we looking for? If this Fx will be greater than this 200 Newton, it would mean that this force is being pulled to the right, or this, this block will be pulled to the right. But if this 200 Newton will be greater than whatever that we find for Fx, that means this object will be pulled to the left. So, okay, now we have Fx is equals to F cos theta, and then this will be 200 cos 30 degrees. Now, when we punch that into our calculator, we get 173.21 newtons. Now, if we have 173.21, compare it with the 200, we can see that it is smaller than the 200. So that means, in other words, the work done will be done to the left. So that means the object, the total net work done will be to the left, meaning the object will be pushed to the left, or will accelerate to the left. So making our option number A the correct option, right? So you saw the thought process that goes into answering those questions. Okay, so now let's move to 1.6. 1.6 says, while a helicopter is moving vertically upwards with a constant velocity, a camera is dropped from it. The camera lands on the ground after t1 seconds. The sketch graph below represents the velocity time relationship of the camera's motion. Then they took downward is positive. Now we can see this is downward is positive because we see our graph is an increasing function here. Then now they're saying the shaded area under the graph represents, is it A, the total distance of the camera, the total distance the camera has traveled? Definitely not, because if it was indicating the total distance, then it would have to be the area under this whole graph here. So they would have to even shade this part to indicate the total distance. Then B, does it indicate the speed with which the camera strikes the ground? Not quite, because if we wanted the speed in which the camera hits the ground, then it would have to be a value in here. So let's say X, for example. So the value in here would have to be the one representing the speed, because remember the speed would have to be on the Y on the y-axis here, right? So this one definitely not correct. Then C, does it represent the maximum height of the camera above the ground? Or D, does it represent the magnitude of the displacement of the camera? Now there's a battle between these two options here. So which means we would have to actually show the trajectory of the camera as it is dropped from that helicopter. Now, because the helicopter is moving upward like this, if we drop a camera, we know that the camera does not just fall into the ground like that. Remember, it has to follow Newton's first law, which says because of inertia, the camera will want to resist the change in the change in its motion, meaning the camera, when it is dropped down, it will first move up, reach a particular maximum height, and then come back to the ground, right? And then that's when it will be going all the way down to the ground here. So this is the trajectory of the camera. This is the part that the camera will follow. So from being dropped, it will kind of follow in that same direction of the helicopter before it reaches that maximum height. And then from reaching the maximum height, it comes back down. So that's why we are seeing this here. If I have to break it down, this is Roman figure 1. So from this part to this part, this is when the camera is still moving to that maximum height. So we'll indicate Roman figure 1. At the time when it reaches the maximum height, that's when it's the y-intercept. Remember, on a velocity versus time graph, this line here, when we see a coordinate, or when we see a value here, this represents the time in which that particular projectile reaches the max height, the maximum height. So when it reaches the maximum height, let's call it Roman figure 2. And then Roman figure 3 is when now it's coming back down to the ground. So this is when it's now making its way to the ground, that's Roman figure 3. So this is the trajectory of the ball, and then these are the corresponding values in terms of your velocity versus time graph. Now we want to understand this shaded area here. We can see that it's in between Roman figure 2 and Roman figure 3, right? Meaning it's in between here. So let's indicate. So that shaded area is this part here. Now, let's now understand and let's now differentiate between these two and then find which one is the correct answer. Now, looking at D, they said, does it represent the magnitude of the displacement of the camera? If it was the displacement, we do understand that the displacement will be represented by this part here. Because what is displacement? The shortest distance between the starting point and the final point, or the ground here. So from start to finish, or from start to final point, that's the displacement. So the displacement would be represented by the distance from Roman figure 1 to Roman figure 3 there. So the short distance here. But then when we are looking at this one here, we can see that it's starting from Roman figure 2 all the way to Roman figure 3. What does this distance here represent? Obviously, this represents the what? The maximum height reached by the camera. The maximum height reached above the ground. And then when we read option C, look at this. Does it represent the maximum height of the camera above the ground? Definitely. So making our option C the correct option here. So again, we did not just close our eyes and see where our pen landed. We actually in the work to solve that. Okay, so we have that. This was C. Now 1.7 says the work done by the car's engine to increase its velocity from 0 to V is W. What work should be done by the engine to increase its velocity from V to 2V? Is it A, 4W, B, 3W, C, 2W, or D, W? Now, considering that the work done or the net work done is equal to the change in kinetic energy of the object, we can now use that to actually find out how they got to this W here. So we'll say W is equals to half M VF square minus VI square. Right. Now, the W is equals to half. Remember, we don't have the mass. We are not concerned about that. The V finally, remember, we are moving from 0 to V. So V final is just V, and then that's V squared. Then V initial is 0, so we'll have 0 square. Now, when we punch all this, or when we calculate here, this is W is equals to half M V squared, meaning that our W is equals to that, right? So they said moving from 0 to V, it's W. And as we can see there, that's our W. Now, if we want to move from V to 2V, that means again, work done is equals to change in EK, and then we'll have W is equals to half M VF squared minus VI squared. So we have half M, and then what's our final velocity? We are moving from V to 2V. So our final velocity now is 2V. So we'll have 2V squared. And then our initial velocity is V, right? So this will be half M. 2V squared here will give us V, 4V squared, and then minus V squared. Right, now 4V squared minus V squared, that's 3V squared. So you would actually agree if I have this as half M and then multiplied by 3 and then V squared like that. Now what I want to do is manipulate this. Check this out. I will now bring the 3 over here and then bracket, write this as half M V squared. So I did not change anything here, simply rearranged. Brought the 3 here and then wrote half mv squared. But then you will remember that half mv squared here, we had indicated that it is equals to W, right? So let's call this equation 1. Now, if W is equal to half mv squared, what is this one now? So this must be equivalent to what? To 3W. And then what is the option for 3W? That's option number B. So that's how you were supposed to calculate that. Okay. And then let's now go to Let's now go to 1.8. It says an ambulance moving at constant velocity, producing a sound, approaches a stationary listener, passes the listener and moves away. So number one, it does what? It approaches. So we're expecting our frequency of the listener to be higher. And then it passes the listener and moves away. So here we are expecting the frequency of the listener to be low. Which one of the following graphs best represents the change in observed frequency? In what? In observed frequency. Note that. In the observed frequency. So frequency of the listener. So this graph should only represent the frequencies of the listener versus time. So number one, we said when the ambulance is approaching, then we are expecting the listener to detect a higher frequency. And then after the ambulance has passed that stationary listener, we're expecting the listener to detect a lower frequency. Now, looking at all these graphs, which one best represents that situation? We can all agree that that is being represented well by graph A, because here frequency of the listener is higher, and then after some time the frequency of the listener becomes low as the ambulance passes away. Okay, so we have option A. And then 1.9 says two identical metal spheres, each carrying charge Q, are at a distance r apart. Which of the following pairs of charges that are made simultaneously will double the electrostatic force that the charge spheres exert on the other, right? So here, I will just go and pick the correct answer and then show you the calculation. So the correct answer here was supposed to be D. And then how you actually find that the electrostatic force has been doubled is by using this. So we know the formula for electrostatic force is K, Q1, Q2 over R square, right? Now we want to do what they are telling us to do here. So which is decrease the distance to R over 2 and then reduce the charge on one sphere, on only one sphere, to Q over 2. So this is F. So for the F nu, we will say we have our K there, and then note that F is equals to that. So Q1, let's have this charge here, and then times Q2. So we are not doing anything to Q2. We are only halving Q1. And then when it comes to distance, what must we do to distance? We must reduce it to R over 2. So there we go, R over 2, and then square like that. So our F nu will now be represented as what? So remember, from here we will get the 1 over 2. And then K, Q1, Q2. Then over, from here, we will have 1 over, remember this is 1 over 2. 1 over 2 square, this will give us 1 over 4, and then R square. But then I want you to pay attention to something. This here is the same as F, right? So looking at what we have here, all of this can just be replaced by F. Then what is our F nu? F nu, we have to say what is 1 over 2 divided by 1 over 4. If you punch 1 over 2 divided by 1 over 4, you get 2. But then the whole of this should be F. So F nu should be twice F. And then F twice F means what? They have doubled the electrostatic force. So the new electrostatic force will be doubled from the previous. Because now what did we do? We decided to decrease the distance to R over 2. And also we decided to change the charge on one of the spheres to Q over 2, or to reduce it to Q over 2. So just like that, we can see that the option that will actually double the electrostatic forces if you do this. Now, all these other ones, if you were to calculate, you would find that they do not double, right? For So for this one, for example, I think it remains the same. Then for the other ones, it's either they quadruple or they are 8 times or 16 times the size. So for the option D here, we had it double. So that means our correct answer is D. Okay, so now we go to 1.10. It says, two objects experience an inelastic collision in an isolated system. Which one of the following combinations regarding the total momentum and total kinetic energy is correct? Note that they're talking about inelastic collision, right? Now you will note that we said whether a collision is elastic or inelastic, the total linear momentum will always be conserved. So this is how you answer these questions. On this side, you are looking for where they will say the total momentum is conserved, because you know whether it's elastic or inelastic, your total kinetic energy remains, your total momentum remains conserved. So conserved B and then D conserved. So there is no point whereby you will not find the total momentum being not conserved. Okay, so total kinetic energy. Now, this is where we draw the line between the elastic collision and inelastic collision. If it's inelastic, we say the total kinetic energy will not be conserved, because remember, with an inelastic collision, that means some of the kinetic energy is lost or transferred from one form to another. And then again, when we are talking about the one that is elastic, we say that one energy is not lost, so energy will not be converted, so it just remains like that. Then we are looking for where it says not conserved. So not conserved is on part C and then also on option B. But then now, when we are about to select the correct answer, we must check where we have two ticks, right? So we have a tick on B this side, and then we also have a tick on B this side. So that means the correct answer is B. Okay, and that's how you are supposed to tackle your multiple choice questions. So all this, I was just trying to show you that when it comes to multiple choice questions, you still need to put in the work. You still need to kind of figure out the concept, everything that you learned from your note, and then also do some kind of calculations. So it's not just a matter of how lucky you are. This is not gambling. It's simply still conceptual, which is the advice that I always give, is that start with your questions from question 2, try to answer all the questions in the question paper, and then when you have 30 minutes remaining till the end of the session, then you can go and check your multiple choice questions, because by that time already you would have seen all those topics, and then now it becomes easy to actually put in the work in trying to solve those multiple choice questions. So I'm against having to start with the multiple choice questions, because mainly you have to think about 4 or 5 topics all at once, right? Because remember, multiple choice questions is asking you everything that will be inside your question paper, right? So it's best that you go through the question paper, and then when you have tried to answer as many questions as possible in your question paper starting from question 2, then you can go to your multiple choice questions and then just try to figure out and then also put in the work to actually find the most correct options.